Hello guys, Mr. Marr here. I am going to be absent tomorrow, so again, pardon my voice. I've got this cold that I'm still fighting. But want you guys to still be continuing working on Chapter 1 as we get through the beginning. So first thing, solving inequalities that I want to go through here. So this is a compound inequality that I'm starting you with, but remember, anytime you're solving an equation, our goal is one thing, and that is isolating the variable. So in this case, we are going to isolate that x, and when we do that, when we add the 3, which would be our first step, we have to do it to each of the sides. Okay. Alright, so now our last step is just to divide by 3, and again we have to do it to all 3 sides in this case, and that gives us this final compound inequality here. Sorry about that. That looks like this. Okay, now this is saying that x is greater than 3, but less than or equal to 5. Now, when you want to graph something like this, what we want to do is mark the numbers that we have involved. And since this can be less than or equal to 5, what we do is we put a solid dot there. And since x is greater than 3, it's just an open circle. And since x is between these two numbers, we draw kind of a line segment connecting those. Okay, so that would be the final answer to that problem there. Now there's one brief rule that you should know about inequalities, and that is the following. So if we solve this here, again, we are just going to be subtracting 4 to isolate that inequality. But now we get to a point where negative 3x is less than 18. Now if I divide by negative 3 here, a normal answer would be x is less than negative 6. Okay? But the problem is here, take a number that is less than negative 6. So for example, negative 10 is a good one. That's a 10, sorry. So if I plug that number back into the original, okay, so if I plug that back in, I would have negative 3 times negative 10 plus 4 is less than 22. And what I would get there is 34, right? Negative 3 times negative 10 is 30 plus 4 is less than 22, which is a false statement. So there is a rule. Anytime you multiply or divide by a negative number, so if I go back here to my negative 3x is less than 18, now when I divide both sides by negative 3, there's a little rule here I have to remember, and that's this. If you multiply or divide both sides by a negative number, you have to switch the inequality. So this x is still x, this is still negative 6, but instead of less than, it's going to become greater than. Alright, so one thing to be aware of when you're working with inequalities. Now the next type of problem I want to go over are absolute value problems. Now most of you remember that an absolute value sign makes a number positive. So in this case, I'm looking for a value of x that when I multiply it by 2 and add it to 3, it equals 5. But remember, there's kind of two things that could end up being in this absolute value. If I get 5, well, the absolute value of 5 equals 5. But also, if I can somehow make inside that absolute value equal negative 5, I'm also going to get a result of 5. Now, because of this, when you solve absolute value problems, you make two equations. Now, one of the equations you're going to set equal to the positive value on the opposite side. So in this case, I basically got rid of the absolute value and said 2x plus 3 equals 5. But on the other side, I'm going to say 2x plus 3 equals negative 5. And then I'm just going to solve that equation as normal. And I'm going to get two different solutions. Okay, so my two solutions here are 1 and negative 4. And sure enough, if you plug those back into the equations, you are going to find the solution is correct. Now the last type of problem we're going to be talking about are absolute value inequalities. So here I have the absolute value and I have the inequalities. All we're going to be doing is taking the two set of rules from absolute value equations and inequalities and putting them together. Now, one thing I want to note, before you solve an absolute value problem, isolate the absolute value. So in this case, before we do any type of solving, we want to isolate the absolute value itself, which in this case means add 4 to both sides. So now I have the absolute value of 3x plus 2 is less than or equal to 9. Now, just like before when I was solving the absolute value problems, I'm going to make two equations. So I'm going to say 3x plus 2 is less than or equal to 9. But my second equation, 3x plus 2, remember, since it's an absolute value, I need to change the sign to negative 9. But since I made it negative, I need to reverse this inequality. Okay? And from there, I'm just going to solve. So in the first one, I get x is less than or equal to 7/3. My second equation, I get x is greater than or equal to negative 11/3. Now, the way we write this final answer is important. Now, I tend to graph the answers before I make any attempt to write my final solution. So, if this is 0 on a number line, 7/3 is a little bit more than 2, so I'm about right there. This is 2. And negative 11/3, this is negative 3, and this is negative 4. Negative 11/3 is right here. Now, what this is saying to us is x is greater than or equal to negative 11/3. Okay, so this graph is heading this way. And then over here, x is less than or equal to 7/3, so this wants to go this way. So we have one of those line segments. So what this means is this is an and statement. Okay, they're not going in opposite directions, so both solutions are true. So we're saying x has to be less than or equal to 7/3, and it has to be in between, or greater than, negative 11/3. So this is how we'd write our final answer. So hopefully these steps will give you some help on the class assignments we're doing today, and we'll go over next time in class. Thanks, guys. Have a great day.